Kyle measured the temperature of a cup of hot chocolate placed in a room with a constant temperature of 70 degrees Fahrenheit. The temperature of the hot chocolate was 185 degrees Fahrenheit at 6 p.m. when it started cooling. The temperature of the hot chocolate was 156 degrees Fahrenheit at 6:05 and 135 degrees Fahrenheit at 6:10 p.m. The hot chocolate's temperature continued to decrease. Of the following functions, which best models the temperature T of M in degrees Fahrenheit of Kyle's hot chocolate M minutes after it started cooling? So let's say you didn't know how to begin this question, but we can always glance at the answers to try to gain some insight on what kind of function this should be. Now, all of these are exponential functions, right? And then we're being asked for which of these equations best models the situation given. Couple things I would like to point out. We're given points here. They just don't sound like points. So we could plug those in. At 6 p.m., the temperature was 185. That at the very beginning, when time was 0, the temperature was 185. At 6:05, after 5 minutes, the temperature went down to 156. So that's another point that we're given. And third, at 6:10, which is 10 minutes after the time we started measuring, temperature went down to 135. So using the back solving method, we could plug each of these x values in these equations and see which one best models the scenario. So an easy number to work with is whenever your x value is 0. So if you plug in a 0 here, you would have 185 times 1.25 to the power of 0. Well, you know anything to the power of 0 is 1. So this is 185. That seems to be working. So because when we plug in a 0 in our point, y was 185, so we can't get rid of that. The second one also seems to be working because this is still, when you plug in a 0, we get 185. The third one, however, if you plug in a 0, this becomes a 1, but then 185 take away 70 is 115. So when we plug in a 0, we were expecting 185. We didn't get that, so that's out. And D, on the other hand, when you plug in a 0, this becomes a 1, and this one still gives us 185. So we were only able to eliminate one of them. So that means we should try plugging in the second point and see if we can eliminate more of these. So let's go ahead and do that. First, I'm going to reset by erasing the first markings, and then we'll do it again for plugging in 5 in each one. Okay, so remember, we've eliminated C. So now we are plugging in this point right here. Plugging a 5 into this part right here. I've already done that in Desmos. You can see it up here top right. You're noticing that when we plugged in a 5, we got 564. Well, we were expecting 156, so A is now out. Let's try plugging it to the other one, the second one over here. The second equation, rather. This part B. Plug in a 5 into it, and you get an 82. Once again, when you plug in a 5, you wanted 156. So B has also failed. So A, B, and C are out. It means the answer is going to be D. But let's double check it. If I plug in the third equation, 70, yeah, there it is. So you see, we expected of 156, and you see that this answer here is really close to 156. So it's got to be D.